Look up at the night sky, and you'll see billions of stars. And you cannot help but wonder, surely, somewhere in that vastness, other life must exist. Now scientists are closer than ever to finding the answer. Thanks to this. Kepler is the most powerful planet hunter ever built. And it's making astonishing discoveries.
The sheer numbers of planets out there is really quite stupendous.
And even finding new worlds like our own.
This might be the first Earth analog around a sun-like star that's ever been found.
Scientists are even beginning to investigate what kind of alien life might exist on those planets. In the oceans of a water world, on a land where the sun never sets, or even on a planet like our own Earth. This is the story of how one spectacular spacecraft has brought us closer than ever to answering mankind's ultimate question. Are we alone? Do aliens exist? Is there extraterrestrial life out there in the universe? These are questions everyone wants to know the answer to, including scientists like NASA astrobiologist Chris McKay.
This represents the same kind of fascination with alien life that I have. I'm searching for life beyond the Earth. I want to answer to the question, is the story of what happened here on Earth with the origin of life and its development into complex, intelligent creatures, has that happened anywhere else? In a sense, these guys think they know the answer, and here's a picture of it. But in a fundamental way, they're asking the same question I'm asking. Are we alone?
Searching for alien life is no longer in the realm of science fiction. In fact, we're closer than ever to finding ET, thanks to the efforts of a new spacecraft.
Seconds.
Cape Canaveral, Florida.
T-minus 5, 4, 3, 2, start, 1, 0.
On this rocket is the most ambitious planet hunter ever built.
Burning out of the solids for separation.
It cost more than $500 million and was 25 years in the making. This is the Kepler Space Telescope. Its 7-year mission to seek out new worlds that might have alien life. And project scientist Natalie Batala has lived with that mission from the very first moment.
To watch it launch was really quite something. This feeling that, yes, finally, after decades of planning, it was finally happening. It was going up there. That was a tremendous moment.
Just a month later, on April the 7th, 2009, Kepler was ready to get to work. The spacecraft jettisoned its dust cover, and Natalie was one of the first people on Earth to see what it saw.
This is Kepler's first light image. It came down to us at NASA Ames about 24 hours after we ejected the dust cover. Most everybody had gone home, except for me. I stuck around. As it filled my computer screen, the image that came to my mind was like champagne filling a glass, with all of these stars being the little bubbles. It was very exciting to see, and I felt a little guilty that I was there enjoying that moment all by myself at 9 o'clock at night. Every single tiny dot that you see is a star.
Kepler is focused on a small patch of the sky near the constellation of Cygnus the Swan. You can see it for yourself on any clear summer night.
The field of view of Kepler is a region of sky about the size of my open hand at arm's length. In that area of sky are 4.5 million stars in our galaxy alone.
But Kepler isn't looking for stars. It's looking for planets that orbit the stars. But that's a problem, because Kepler can't see planets. Planets are much smaller and dimmer than stars, so they get lost in the glare. And this spotlight shows why.
Okay, let's imagine that there's a moth flying around that spotlight. Could we ever hope to see the moth? No way. The moth, although it does reflect a tiny bit of the spotlight's light, it's far too feeble for us to see that.
But there is a solution.
If the moth passes in front of the bright light, a little bit of the light that was going to reach us obviously gets blocked by the moth. Then we are able to detect the moth by measuring very carefully that very subtle change in the total brightness of the spotlight.
The bigger the moth, the more light it blocks, and the more the light dims.
In exactly the same fashion, that's how we can detect small planets orbiting other stars and even measure their sizes.
So to find planets, Kepler has to continuously watch thousands of stars. If a planet passes in front of its star, it'll make the star dimmer, just for a short time. If you plot the brightness of a star on a graph, this event shows up as a dip. And right from the start, Kepler saw stars dimming. In just its first 6 weeks, Kepler discovered 5 new planets, including Kepler 7b, a huge gas planet, larger than any in our solar system. As the months went by, the numbers grew at an even more rapid rate. By June 2010, 15 months after launch, Kepler had found over 700 potential planets. Once, it took months to find a planet. Now they were coming in at a rate of almost 2 a day. But this was only the beginning. Soon Kepler would find what it was really looking for. Worlds that might be capable of sustaining life. The Kepler Space Telescope is designed to answer a profound question. How many other worlds are there in our galaxy? And how many of them might be able to support life? In just its first year, it discovered an unprecedented number of planets, over 700.
The sheer numbers of planets out there is really quite stupendous. Here you see just a small sample of them. And the planets range in size from, a half the radius of the Earth up to things that are several times larger than Jupiter even.
Some of these planets are truly bizarre. In 2011, Kepler discovered a world that's a vision of hell.
Kepler 10b is a scorched world. It's got an ocean bigger than the Pacific Ocean, that it's an ocean not of water, but of molten lava. That star-facing side, as it orbits, has surface temperatures in excess of that required to melt iron. So this is a blowtorched world.
And just a few months later, in September, the spacecraft discovered Kepler 16b. It orbits not one, but two stars, just like Luke Skywalker's home in Star Wars.
An iconic favorite from Kepler is nicknamed Tatooine, because it orbits two stars. If we could visit, you would have two suns in your sky rising and setting at different times. It would probably be bad for astronomy.
These worlds are fascinating, but Kepler's mission is to find not just alien worlds, but worlds that might be inhabited. So what are key requirements for life? To answer that question, we have to look at the one place in the universe that we know has life. The Earth.
We know that the Earth is habitable, indeed inhabited, and so surely there's some drive to find another Earth-like planet elsewhere in the universe.
Humanity is on a quest to find life. Kepler's objective is first to find out if planets like Earth, where we have this one example of life, if planets like that exist.
So what is it about the Earth that makes it the perfect place for life? NASA astrobiologist Chris McKay has spent years investigating that question. And he's found one thing essential for all life on Earth.
We have never found an organism on Earth. The driest, coldest places, and we've looked, and boy have we looked, we've never found an organism that can make do without liquid water.
So life as we know it needs liquid water. Fortunately, water is made of two of the most abundant elements in the universe, hydrogen and oxygen. We've even detected water vapor in the clouds of gas in outer space. What's harder to find is liquid water. Because to have liquid water, you need to be at just the right temperature, like the Earth is.
The sun is like a fire. It provides light, and through that light, warmth. And that warmth is what keeps the planet warm enough to support liquid water. If it's too far from the sun, the water will be ice. If it's too close, the water will be steam. So it needs to be right in that zone where the water can be liquid. Sometimes we call it the Goldilocks zone. It's not too hot, it's not too cold, it's just right.
Kepler's mission is to find a planet in this Goldilocks zone. And the key to that is the speed at which the planet orbits the sun.
When a planet is very close to the star, it's going around quite rapidly. The period is very short. It can go around in weeks even around the central star. As the planet is further away, it takes much longer.
A planet that orbits once a week will be close to its star and very hot. A planet that orbits every 10 years will be very far away and too cold. So scientists were looking for a planet with an orbit similar to Earth, roughly once a year. But to detect a planet, you need to see at least 3 transits, which means gathering data for years. Month after month, Kepler kept watching. Until finally, on the 5th of December 2011, it found what it was looking for. Kepler had discovered its first planet in the habitable zone, Kepler 22b, over 600 light-years away.
Kepler 22b was the first confirmation of a planet that is at just the right temperature. So it's in the Goldilocks zone. It's orbiting a star very much like our own sun, actually, a G-type star, in an orbit that's somewhat similar to our own Earth's orbit around our sun. Its orbital period is 289, almost 290 days.
The temperature on this world could be very similar to our own. It might even be home to alien life. But to understand what kind of life, we need to know what kind of planet it is. In our solar system, there are two kinds of planets. Huge gas giants like Jupiter and Neptune that have no solid surface, and small rocky planets like the Earth. Kepler 22b is in the middle. It's about 2.5 times the size of Earth. Bigger than all the rocky planets we know of, but smaller than the gas giants. So what is it?
So far, what we can tell is that the planet is probably not purely solid. It's not a big ball of rock. And from the study of other planets, all of those somewhat larger than Earth planets have lots of water and also perhaps some atmosphere. So by association, the bet is that Kepler 22b will be a rocky planet with a very dense and thick ocean.
If Jeff is right, this would be a planet completely covered in water. It's the perfect planet for a paddle. Jeff can imagine what it would be like to kayak on Kepler 22b.
If you were kayaking on Kepler 22b, you'd look overhead, you'd see a host star that would remind you of our own sun here, a yellowish star about the same size as our sun. What's interesting about water, even on Kepler 22b, is that the density would be about the same as the water we enjoy here on the Earth. No different, really. The gravity of the planet might be a little higher, a little lower than the Earth, but not so different.
But look beneath the surface, and this ocean is unlike anything on Earth.
The ocean would be thousands of kilometers thick. There would be no ocean floor to dive down and visit because it would simply be too far away.
Even so, Kepler 22b could have the essentials for life: liquid water and energy from its sun. And perhaps it could have a whole ecosystem living in its endless ocean. But what would it be like? Many scientists believe there are things on Earth that we'll also find on other planets, like photosynthesis, collecting energy from the sun.
One fundamental function that life needs to be able to perform is to gather energy for itself. Now, because sunlight is such an abundant energy source here on Earth, and for any planet orbiting another sun, we'd expect photosynthesis, and therefore possibly things like plants, to be pretty common out there in the galaxy.
So could there be plants on our water world? If there are, they'll have to cope without any ground to grow in.
On a water world, the main challenge that these plants are going to face is remaining buoyant. You can't start sinking down beneath the water too far, perhaps by having bladders filled with gas that help you to buoy up in the water.
This alien seaweed could provide food for animal life too. But what might these animals look like? Jeff Marcy thinks we can speculate.
We have some ideas just from the laws of physics. Any species on a water world orbiting another star would want to propel itself rapidly and therefore would be streamlined in its design. It would need a propulsion system, fins. It would need to gather nutrients. It would have to have something like a mouth, and it would probably want sight, and therefore it would have something like eyes. So we get some idea, albeit somewhat geocentric, that life elsewhere might have some properties that are reminiscent of life here on Earth.
So could our aliens look like this? They seem somewhat familiar. That's down to something called Convergent Evolution.
Now these two animals here look very, very similar. They look like hedgehogs. But actually only this creature on my lap here is a hedgehog. He's making a spirited bid for freedom. And this other animal here is actually entirely evolutionarily distinct. This is a tenrec. The tenrec is actually more closely related to the elephant than it is to the hedgehog. So this is a really nice example here of how evolution, quite often when it's trying to solve the same survival problem of avoiding being munched by a predator, two very, very different evolutionary lineages will converge on the same solution.
So two unrelated animals can end up looking almost alike. Just as dolphins and fish have evolved a similar shape. So the same forces of evolution could have created the fish shape on an alien planet.
So some fish might be herbivorous, they might be nibbling at these fronds, but then you'd also get fish preying on those herbivores. So you'd have prey fish and predator fish.
There are features of hunters on Earth that we might find here as well. Lone hunters are generally bigger than their prey, have sharp eyes, and even sharper teeth. But there will probably be differences too. On Earth, fishes have jaws that open vertically, but they could just as easily move sideways. Just as it does on Earth, the struggle between hunter and hunted will drive evolution. But without land, this is no place like home. There's no chance of little green men living here. But Kepler soon found a planet which might well have plenty of land for aliens to live on. Thanks to the revolutionary new Kepler spacecraft, we're closer than ever to finding out whether ET is out there. We now know of hundreds of alien worlds that exist in our galaxy. But what scientists really want to find is a planet a similar size to our own. Because an Earth-sized planet has the best chance of having oceans and continents. On the 28th of February 2012, nearly 3 years after launch, NASA announced the discovery of over 1,000 potential new planets. One of these was orbiting the star KOI 2626. It's about 1.5 times the size of Earth, smaller than a water world. Small enough that it's likely to be rocky. But there's a problem. This planet doesn't orbit a star like our Sun. It orbits a very different kind of star, a dwarf star.
When I was a kid, I was told in school that the Sun is an average star, which is a complete lie. The Sun is not an average star. Most stars in the galaxy are much less massive and put out much less energy than the Sun. And we call these very low-mass stars M-dwarfs. Our Sun is yellow in color, very massive, very large, and compared to it, these low-mass M-dwarf stars are tiny. They're only about 10 or 20% the size, 10 or 20% the mass, and they only put out 1/1000th the amount of energy.
This star, also called a red dwarf, is so feeble you might think this planet would be too cold. But in fact, it's just the right temperature.
An M-type star provides much less sunlight than our star. To get the same amount of warmth, just like this dimmer fire, you have to move in closer. There's still a habitable zone. You can get close enough to the star that it's warm enough for liquid water.
But being so near to a star can create a strange situation. Gravity from the star pulls more strongly on the closest side of the planet, a slight drag which can cause one side to always face the star. Astronomers call this tidal locking. This world would have a sun side that's always hot, and a dark side that's always cold. At first, it seemed this would make life impossible on the planet, as there'd be no atmosphere to sustain it.
When we first conceived of the notion of a tidally locked planet, even in the habitable zone, the thought was, well, on the dark side, it's going to be very, very cold. So cold that the atmosphere could condense out completely. All the carbon dioxide that would normally be in the atmosphere would be present as ice, forming a giant polar cap on the dark side. Ice like this. This is a chunk of carbon dioxide.
But atmosphere expert Kevin Heng wasn't so sure. He set out to investigate the climate more thoroughly. He builds computer simulations of alien atmospheres. He's a kind of interplanetary weather forecaster. Kevin used what we know about the red dwarf planet to simulate the atmosphere. And this is what he came up with.
What you're seeing is a temperature map near the surface. Right in the middle of the map is the point where the temperatures are expected to be the highest.
And this temperature difference between the hot side and the cold side has a profound effect on the atmosphere. Here on the dark side, the air cools and sinks, spreading out round the planet. That creates a wind that blows along the surface to the hot side. Here the air heats up and rises before returning to the cold side. So if this planet has an atmosphere, it would have a permanent planet-wide wind system. This reduces the temperature difference and keeps the atmosphere from freezing. Which means this planet might be habitable after all, with a stable atmosphere and a pleasant climate.
You probably want to live close to where the day side transitions into the night side, the so-called day-night terminator, where temperatures are between 10 and 20 degrees Celsius. So a good spot for real estate.
Standing in this real twilight zone would be pretty strange. You'd be stuck in a permanent cocktail hour, bathed by a sun that never sets.
On this world where the sun doesn't move, sunward is too hot, away from the sun is too dark and cold. The habitable zone may be just this zone right here, where the sun is at perpetual sunset. Standing here, looking out, we would see a red dwarf star. It looked much redder than the sun viewed from Earth.
Any plant life on this planet would have to adapt to this endless deep red sunset. Here on Earth, plants use chlorophyll to collect the sunlight. This green pigment is adapted to harness the yellowish light of our sun. But plants here would need to collect more red and infrared light. Scientists think they would most likely be black. The darker the pigment, the more visible light it absorbs. So by being black, these plants would absorb the maximum amount of energy from the weak sun.
Plants might find the situation actually easier to contend with because the sun isn't moving through the sky. You can just point yourself like a solar panel towards the sun because it never moves. But actually one of the other features of a tidal locked planet would be the fearsome winds blowing constantly in the same direction. So maybe a flat panel wouldn't actually end up being the optimum design, and you want to be a bit more flexible and giving to allow the wind to kind of blow through your perhaps fan-like shape.
But if there are plants on this world, could there also be animals? Lewis Dartnell thinks we might find creatures collecting organic matter created by the plant life in a very clever way.
On Earth, we find filter feeders, life that filters particles or little grains of food out of the water as it wafts past them. On a planet like this, we might find a similar strategy on the land. So maybe we'd find something like land whales that aren't filtering out plankton from the sea like the whales in our oceans, but are great big static animals that try to filter out particle matter from their wind to feed off.
They're not going to get a lot of food that way, so these creatures would have to conserve their energy by letting the wind do all the hard work. Being static won't be a problem, as long as there are no predators here. But there is a danger they'll face, which could prove fatal. Solar flares.
These stars can be very active. They are typically much less bright than the sun, but can occasionally flare with huge eruptions. So an organism sitting on a world exposed to that radiation would suddenly be bathed in X-rays and UV light.
Even with a thick, scaly skin, this radiation may be too much for life to survive on the sunlit side. But what about the dark side? There's no sunlight here, but Lewis thinks there might still be a way for photosynthesis to occur.
Maybe we'll find photosynthetic life even in the permanently night side half the world, growing by the light of aurora, where there'd be just enough trickle of energy to support microscopic photosynthetic life forms in this eternal night.
But this feeble light probably can't support much more than simple single-celled organisms. To have the best chance of finding complex life, Kepler needed to find a planet that wasn't tidally locked. A planet that orbits a sun more like our own. A planet in the crucial habitable zone. And a planet that's rocky, a similar size to the Earth. For all its success, Kepler hasn't found a world with all these characteristics. Until now. This is the star with the snappy name KOI 701. In early 2011, Kepler saw signs that it had not one but 3 orbiting planets. This was an alien solar system, and the 3rd planet out looked like it might be in the habitable zone. But there was a lot of work still to be done. Before they could investigate if this planet could sustain life, they had to double-check it actually existed. So Jeff got to work using a huge telescope in Hawaii.
So we're just a few seconds away from going to KOI 701. Our job is to verify these planets. Are they really planets, or are we being fooled in some way?
Exposure complete.
And we are ready to go. So we're heading now to KOI 701. Here we go. You can see the coordinates of the telescope changing. The telescope on top of Mauna Kea now is slewing over to the coordinates of KOI 701. And there it is. That's it right there. Fantastic.
But But although Jeff confirmed it was a habitable planet, there was a problem.
The third planet out, that planet is in the habitable zone, but it's also large, like 22b. It's like Kepler 22b. It's, probably a water world.
The team was about to go public when something extraordinary happened.
So 701.03 was done. In the bag, nice ribbon tied around it, ready to go off to the publisher for publication, when we got an email from one of our team members telling us that he'd spotted what looks to be another interesting signal in the data.
What Natalie's team member had spotted at the last moment could turn out to be Kepler's greatest achievement yet. KOI 701 didn't just have 3 planets orbiting it, there were 4. This 4th planet was in the right place and the right size.
We examined the data more carefully, and there is another planet that is smack in the habitable zone, and it's only a little bigger than the Earth.
Bingo. It was exactly what Kepler had been searching for. A planet in the habitable zone, small enough that it could be made of water and rock, like the Earth.
And so this is something you could stand on, something that's rocky.
This might be the first truly Earth analog around a sun-like star that's ever been found.
This planet is over 1,200 light-years away. Even our fastest spacecraft would take many millions of years to reach it. But this is the most Earth-like world we've ever found.
And that's the amazing planet that has the hairs standing up on the back of my neck.
And the most promising home for alien life. Kepler has now discovered a world small enough to be rocky like the Earth, and in the right position to have liquid water. It's an astonishing thought. This new planet may have oceans and deserts, mountains and rivers, just like our own. And it could even have life forms every bit as varied as on Earth. Life in the seas, in the skies, and on the land. But being 40% larger than Earth, 701.04 will have one big difference. It will probably have stronger gravity. In this alien world, everything we take for granted here will be that bit more difficult to achieve. And the creatures themselves will have to adapt.
Animals will respond to the increased gravitational pull on a larger planet. And so they would want to have body plans which are also very strong, so with column-like legs to support their increased weight, and not kind of spindly, thin legs.
Alien creatures on 701.04 might even evolve a greater number of legs. Is that possible? On Earth, there are creatures like spiders and crabs that walk on 8 legs. But large animals are built in a completely different way. They have 2 or 4 legs. So is it even possible to have a large 8-legged animal? Bill Sellers might have the answer. He studies biomechanics, how animals move. He's even worked out how dinosaurs walked the Earth by simulating them on a computer.
When we have an alien life form, we treat the shape of the animal as the framework of the robot. We add motors to actually drive the creature. And then the trick is that we get the computer to learn how to be the most effective driver for this particular shaped animal.
Bill applies the same technique to an alien creature with 8 legs. Could such an animal exist? And if so, how would it walk? Using a genetic algorithm, first the computer generates hundreds of random movement patterns and tests them out. At first, the results are unimpressive.
This is a moving forward start. But as you can see, what happens if it gets the pattern wrong, then although it's still moving its legs, it's lost all forward velocity and actually is starting to go backwards in a very unstable way. Other examples of failures, for example, this one, what happens is the front pair of legs trip over and then the whole thing nosedives, and because of where the weight is, the back legs are up in the air and spinning round. So again, this is a complete failure and we wouldn't work from those.
But the computer takes the best of the random patterns and produces new variations. Repeating this process thousands of times and using weeks of supercomputing power, the alien finally learns to walk.
After the evolutionary process is finished, we end up with these very stable, very efficient gaits. What the work has shown is that this eight-legged creature mechanically could cope with higher gravity.
So it is at least possible that this new Earth-like planet could have animals with 8 legs walking across its surface. But there are other features the additional gravity might give our new aliens.
With a stronger gravity, you don't want to keep leaning forward and pulling back up again and leaning forward and pulling back up, because you're constantly lifting yourself against that gravity. So maybe grazers eating the low-lying vegetation on this planet would have some kind of trunk-like appendage, like an elephant, so they can just hang down their mouth parts and graze and munch up the plant life without having to keep stooping down to it.
Of course, it's still early days, and scientists can only speculate. But thanks to Kepler, we now know there are other worlds where alien life forms may exist. The trickle of planets before Kepler has become a flood. And what will really please alien hunters is just how many habitable worlds there could be out there.
About 900 of these planet candidates are what we'd call super-Earth size or smaller. Super-Earth goes up to maybe twice the Earth's radius. So what this collection of exoplanet candidates is telling us is that small planets, planets like Earth, might be common.
These very small planets are coming out in an avalanche, a tsunami.
Based on the Kepler data, scientists estimate that 1 in 6 stars has an Earth-sized planet. There could be 17 billion Earth-sized planets in our galaxy alone.
Well, we are at a remarkable moment, actually. The Kepler Space Telescope has identified several thousand planets. But what's unexpected and remarkable is that we're finding planets that are a little bit larger than the Earth, that, as far as we can tell, have the correct composition, rock and water, suitable for life as we know it.
Kepler is still out there, searching, with enough fuel to carry on for years to come. But already it's shown that planets like the Earth are common. Surely,